Hello dear students, welcome to another interesting video about parent functions. So in this video I will be discussing the basic parent functions through which all other functions are derived, and we're going to be discussing the domain and range of these parent functions. So these functions on the board, which took me a while to draw, are some of the parent functions, and I have plotted the graph as you can see. So let's begin with the first one. The first one is called identity function, which we also call as y is equal to x, or f of x is equal to x, where the y value is equal to the x value. Now let's analyze the domain and range of this function. So you know that in this case, is there any restriction on the value of x which the function can take? If you look at the graph, this graph line continues without any interruptions. Hence, there is no restriction. Therefore, we can say that the domain are all real values, or negative infinity to positive infinity without any interruptions. Now let's look at the range, guys. Again, the range, this line extends all the way till negative infinity and all the way till positive infinity from this side, and there are no interruptions. Therefore, the range also includes all values starting from negative infinity to positive infinity. Let's move on to the absolute value function. Now, as we know that whenever we have an absolute value sign, and the value inside, regardless of whether it is positive or negative, will always give us a positive output. So let's say, for example, even if x is negative 5, the output is positive 5. Okay, and we already know the positive already is giving us the positive output. Okay, the only thing is this sign, absolute sign, changes the negative to positive as well. So let's look at if there are any restrictions. I do not see any restrictions in a domain, since it extends all the way till negative infinity coming to 0. 0 is included, so there are no interruptions, and then it moves towards positive infinity. So I can say that the domain is from negative infinity to positive infinity. The range, now here's the thing, if you notice that the range, so the y value will never ever be negative. Hence, I can say that the range begins from 0, now including 0. Therefore, I'm going to make a square bracket including 0 all the way to positive infinity. Let's move on to the next one, quadratic. Again, do you see any restriction in the domain? You see, we are coming all the way from negative infinity all the way till 0, including 0, and then moving towards positive infinity. Hence, there is no restriction. Hence, we can say again, the domain is from negative infinity to positive infinity. The range, guys, again, look at the function f of x is equal to x squared. So regardless of whether the x value is positive or negative, it will give us a positive result. Hence, the range can never be negative. It begins from 0, including 0. It goes towards positive infinity. Let's look at the next one, cubic function. I do not see any restrictions in the domain again. Hence, I can say that the domain is from negative infinity to positive infinity. The range, same. The range, this extends till negative infinity, and this extends to positive infinity, and there is no interruption. All values are included. Hence, I can say the range is also from negative infinity to positive infinity. Let's move on to the reciprocal, guys. Now, here's the thing. If you look at the function f of x is equal to 1 over x, if you remember, we have already discussed previously that whenever you have a fraction, the denominator will never ever be 0. Hence, if you see here that although the domain does approach towards 0 but is never 0. Hence, we would say that the domain can be values starting from 0, not including 0. Therefore, I would use a normal bracket, not including 0, all the way towards positive infinity. Can the domain be negative? Let's see. Well, can I use 1 over negative 1? I can, right? And then can I use 1 over negative 2? I surely can. So let me plot the graph here. So again, the domain will approach towards 0 but will never be 0. So 1 over negative 1 is negative 1. 1 over negative 2 is negative 0.5. 1 over negative 3 is even lesser, and so on. So this is what I have. I had forgotten to plot this. Okay. You will see that the domain will never be 0. You see this? The domain can never be 0. It's approaching, but hence I would say that before I write this, I should write that the domain can also be from negative infinity till 0, not including 0, union, again from 0, not including 0, towards positive infinity. Let's move on to the next one, reciprocal squared function. Now, the difference between reciprocal and reciprocal squared function is that any value of x, even if it is negative, it will be squared and make this whole thing a positive. Once again, the denominator can never be 0. Hence, you're going to see that the domain does approach 0 but will never be 0. So I can say that the domain starts from negative infinity till 0 and then union 0 till positive infinity. Okay, again this bracket shows that this is not included. This bracket shows that 0 is not included. Let's move on to the range. The range here is, again, let's see what the range is. I see it moves towards positive infinity, but it will never be 0 overall. So we can say that the range is from 0, not including 0, to positive infinity. We forgot the range for this one. So let's look at the range. It does come from negative infinity towards 0, but never 0. So I would say negative infinity towards 0, union. Again, from 0, it goes towards positive infinity. Let's move on to our second last one, square root function. Now again, I'm taking the square f of x is equal to plus square root of x. We know that the domain can never be negative. In a square root, the radicand can never be negative. Hence, it's going to be the domain can only be from 0, including 0, until infinity. Now the range starts from 0, moves towards infinity. Starts from 0, including 0, towards infinity. Let's look at the last one for today. Cube root function. Now if you look at the cube root function, the x value can be negative as well. Hence, you see that there are outputs on the left side of the y-axis as well. So x can be negative, and I see no interruption. Hence, the domain can start from negative infinity all the way to positive infinity. So the domain from negative infinity all the way to positive infinity. Now the range again, if you look at this graph, it continues going down forever. Hence, the range is from negative infinity and then it continues towards positive infinity. So the range is from negative infinity all the way to positive infinity. I hope that this lesson is very clear to you guys, and these are the parent functions. Thank you so much. I'll see you guys in the next video.